Welcome everyone to this video. I am Mr. Ish. We are looking here at this question and we will solve it. A differential equation, second order, non-homogeneous. We have over here d square y dx square plus 2 dy dx plus 2y is equal to 85 sine 3x. You know, in shorthand representation, this is exactly what we have, is equal to what you see over here. That function is not equal to 0, it's equal to a trigonometric, therefore it's non-homogeneous. But you would start with determining this because your general solution would be equal to a complementary function coming from here plus a particular integral function which would be coming from here, the function you have on the right hand side. When you look over here at the general solution, you're just looking at this. You know, if y is equal to e to the power of rx, the first order derivative is r e to the rx, the second order derivative is r square e to the rx. You plug in these items over here. I have here an r square e to the rx plus 2r e to the rx plus 2 e to the rx is equal to 0. You can isolate the exponential and take it on the other side, it will zero out. You are in essence looking at r square plus 2r plus 2 is equal to 0. Well, you would bring in the quadratic formula. You know, you do minus b plus minus square root the discriminant divided by 2a. I'll have here a minus 2 plus and minus b square, which would be a 4 minus 4ac. Here it's an 8 divided by 2. When you complete this out, you have a minus 2 plus and minus square root of a minus 4 divided by 2. When you bring this up over here, what do you have? You have here a minus 2 plus and minus 2i over 2. Simplify it even further, you're looking here at minus 1 plus and minus I. When you look over here at these complex solutions, we have complex conjugates. You're looking here at a plus and minus bi. You know over here a is equal to minus 1 and b is equal to 1, the coefficient I. And now you know you have to bring this into your template for your complementary function. What is that template? It's a template you are familiar with from solving homogeneous differential equations where you have imaginary or complex solutions. And let's show you that template. My template is this: y is equal to e exponent ax. Then I'll have here a constant cosine bx plus another constant b sine bx. You see these capitalized a's and b's, those are your arbitrary constants, but these lowercase a and lowercase b correspond to the a and b from your solution. When you put everything here into your form, you have over here y is equal to e exponent minus x. Then you'll have a cosine b is a 1, you don't even have to bring it in, plus b sine x. Here's your complementary function and we're done with that. Now we have to determine our particular integral. I will not write this again until the very end, but I will keep these in mind. I have over here a is equal to minus 1, b is equal to 1, and then we'll bring it in at the very end after having determined the particular integral. Our particular integral is coming from right over here. It will be of the form which is trigonometric. Y is equal to a certain constant cosine x. But we have a constant over here too, so we're going to bring it in. Cosine 3x plus d, another constant, sine 3x. This is what I have to run through. First order and second order derivatives, then we'll bring them in. Now when you're looking at this, what are your derivatives? It's easy. When you look over here, you have a minus 3c sine 3x. When you look over here, you'll have a plus 3d cosine 3x. Now run this again for the next derivative. Here you'll have a minus 9c cosine 3x. And here you'll have a minus 9d sine 3x. This is what I have. These items have to be brought into your equation in place of this, this, and this. Look right over here along with this. I have a minus 9c cosine 3x. Then I'll have a minus 9d sine 3x. Remember, my main template is this right over here. Now look right here. Plus 2 times everything over here in the first order. I'll have here a minus 6c sine 3x and then a plus 6d cosine 3x. That's what I have. And then lastly, my 2 times your basic 0 order derivative. When you do that, you'll have a plus 2c cosine 3x. And then you will have here a plus 2d sine 3x. Now coalesce or collect all of your items. My cosine 3x terms are what? I have here a minus 9c. I have here a plus 6d. Then I have over here a plus 2c. Let's bring our sine 3x terms. I have here a minus 9d. Then I have here a minus 6c. and then I have a plus 2d. Now we'll start doing our computations. I'm going to remove this because I don't need to see it any further. When I look at my cosine 3x terms and I simplify this, I have here a minus 7c plus 6d is equal to what? There's no cosine term over here, it's equal to 0. When I look here at my sine 3x terms, I bring these together. What do I have? I have a minus 6c and then minus 7d is equal to what? The sine 3x coefficient, which is 85. These are my systems of linear equations, which I will work with. I don't need to see this anymore. And just to create space, I'm removing even this because I only need my original template, which is right here, my 0 order or my function. I'll take this top part, I'll multiply by 6, I'll take the lower part, multiply by minus 7. When I do this, I have here a minus 42c plus 36d is equal to 0. When I look over here, I have a 42c plus a 49d is equal to 85 times a minus 7. What is that? Minus 595. Let's add these. These cancel out. This is here, and 85d is equal to minus 595. Solve for d. D over here is equal to minus 7. Now let's determine c from this equation right here. I have a minus 7c plus 6 times minus 7, which is a minus 42 is equal to 0. You can easily determine c is equal to 42 divided by minus 7, which is a minus 6. C here is equal to a minus 6. We have everything needed now to present our general solution. Is equal to my complementary function a and b. You know the template was y is equal to e exponent ax, which was e to the power of minus x. Here's my a minus 1 coming in. Then I have a cosine bx, which is just an x, plus b sine bx, lowercase bx, which is this. Here's my complementary function. I presented it before. Now we'll add our particular integral for this part, and it's coming from these values, minus 7, minus 6, to fit over here. I will have over here, c I know is a minus 6 cosine 3x, and d is a minus 7 sine 3x, and here's my solution. The top part is my complementary function, this part right here is my particular integral, and it'll be done. So this right here, everything in its entirety is our solution, and it's correct. And that brings us to the end of this video.